Ooh, hello, everyone. We're at the end of week 2. I'm going to cover something called dictionaries. This is another type of data structure. And then towards the later end of class, we're going to put things together. In particular, we're going to do something called data structures and attempt to combine lists and dictionaries. This is going to help us a lot with the next programming project. The next programming project, I already released it. It's called Weather. I'll pretty much open this notebook next week and give folks a bit of hints on this. This next project is really just checking to see if we can navigate a data structure. In particular, dictionaries with lists inside of it. Okay, let's go ahead and jump into these dictionaries then. Okay, so in the Jupyter server, I'm going to open up lesson number 7, dictionaries. Oh, you know what? Before I even jump into this notebook, I think it would be a good idea to give a sneak peek. So I'm actually going to make a brand new notebook. You don't have to do this, but I'm just going to give a quick sneak peek before we jump into it. Okay, so I just made a new notebook. I'm just going to start from scratch. Uh, a dictionary is kind of like a list, but it'll store key value pairs. A couple days ago, we saw lists. Right, so I'll pull up the list real quick. Right, a list stores kind of like single elements next to each other. A dictionary is kind of like that, but it's going to store pairs at a time. So back to this empty notebook. One example of one example of storing pairs would be like student IDs. You know how student IDs are associated with a name? You could do something with this. Like let's say I made a variable called I'm just going to call it data. All right, let's say I had a variable called data, and this is going to store something called a dictionary. So a dictionary, it's going to use some syntax, the curly braces. So today it might be easy to get confused with curly braces, square brackets, and parentheses. So I'm hoping to clarify all of those different symbols. So these are curly braces, which represent an empty dictionary. So if I were to run this right here, press play, it doesn't do anything, but the kernel now has an empty dictionary called data. I'm going to take advantage of the Jupyter notebook showing the value of the last run value. So I'm going to take advantage of that, and we see that, yeah, data is just an empty dictionary. We can go ahead and start filling it in. I'm going to do on multiple lines, so I just press enter right there. The reason why is so we can have the pairs look a little nicer. Let me go insert my first set of pair. Once again, the scenario we're dealing with are student IDs that are associated with a name. So we could store a key value pair here, like let's say a student has the ID number 12345. I'm storing this as a string, by the way. The reason why is because some students have leading zeros in the beginning, and if I were to represent this as a number, the 0 will actually get ignored. Right? For example, in here, if I did the literal 1, 2, 3, 4, right, this evaluates to yeah, it doesn't evaluate correctly. So I'm going to stick with a string. Okay, so a string here. Let's say Charlie is associated with this. Okay, let me press play. There we go. Our dictionary now has one value. It's not 2, by the way. It's 1. Right, one key value pair. So here, let me formalize things a bit. So this is an example of a dictionary, which is a collection of key value pairs. In this case, this is the key, and then Charlie is the value. And once again, just to prove that there is only one thing in here, right, I'm going to wrap this data structure in the length function, and it evaluates to 1. Right, so I'll print it right here. Length of dictionary is, length of dictionary is 1. Okay, let's go ahead and add another key value pair. These are separated by commas. So I'm gonna put a comma right here and then enter and add in another pair. Like let's say there's another person named Alice who has 2, 3, 4, 5, 6. Okay, now I'm press play and we see that our dictionary now has 2 elements, right? 2 key value pairs. There we go. That's the kind of what a dictionary is. It associates a key with a value. There are a couple important properties in dictionaries, like something called uniqueness. For example, we can't really have the same key, right? We can't have 2 of the same key. For example, if I were to kind of make this duplicate one, right? Like let's say there's another key that's the same as Alice, right? But this person is named David, right? This is impossible in a Python dictionary, right? What's actually going to happen? It's going to override Alice right here. So this third one is totally going to remove this first one. So if I go ahead and run this, right, press play, we see that the length of dictionary is still 2. Right? The reason, if we look at the data right here, right, I'm taking advantage of Jupyter Notebook showing the last run. So let's go ahead and visualize it. Right, data contains only 2 elements. Alice got removed, right, because of this key here. Okay, so that's kind of an important property here. So let me make a comment here. It's impossible to have 2 duplicate keys. Right, this kind of makes sense, right? Like imagine the Cabrillo system, the student ID to name. Right? You can't have 2 of the same ID. But the reverse is not true. We can have 2 of the same value, right? Like let's say there's another key value pair here, right? And let's say there's another person named Charlie, right, that has a different ID number. I'm just going to make up a number like 9999. This is possible. The length of the dictionary here will be 3. Right? I just press play. It's 3, and now we have 2 Charlies. Right? One associated with this key, and another one associated with this key. Okay, so I hope that kind of is a quick sneak peek. Right? Possible to have 2 duplicate values. I hope that kind of makes sense. You can imagine the database at Cabrillo. Right? Some people have the same names, but different ID numbers. Okay, just a little bit more sneak peek on dictionaries. Let's kind of talk about how to access certain elements. You might remember from the lists lab or the lists lesson. So here's the lists lesson here. Right? You might remember we could access elements with a square bracket notation and a index inside of it. Dictionaries are similar, but they're going to be accessed by the value of the key instead, or the key's name instead. Right? For example, if I said data, right, I can't really access 0 here. It's actually going to give us a key error. Like it says 0 doesn't exist. Right? This is not a list. The lists are indexed by their position, but dictionaries in Python are indexed by the name of the key. So if I wanted to access this ID number, right, I would put that here as a string, 0, 1, 2, 3, 4, 5, and this evaluates to Charlie. Okay, hope that kind of makes sense. We're accessing by key, and it gives us the value, which is Charlie. Okay, and similarly, 2, 3, 4, 5, 6, 7, right, this evaluates to David. Right, once again, that's because this David overwrote this second one. Okay, another quick sneak peek on this. We can override dictionary elements. Like let's say Charlie decided to change their name. Right, so Charlie is located at this key right here, 9999. Let's say Charlie decides to change their name. It's possible to change a value of the dictionary. You just use something called the assignment operator, which is a fancy word of saying equal sign. Right, so I'll set this value equal to another one. Let's say Charlie decided to change their name to Charles. Right, so I'll go Charles and then Press play, and there we go, right? It overrode it. We don't see anything here, so I'm going to put data down here so Jupyter Notebook will show the value. Okay, and yeah, there we go. We see the name got changed. Okay, so this is just an example of reassigning a value. Okay, people cool with this so far? Any questions about the sneak peek? All right, cool. Towards the end of today, we'll see a large dictionary. For example, you might have heard of something called a JSON file. This is short for JavaScript Object Notation. This is a way of storing data. And towards the end of it, we're going to kind of decrypt what this is right here. So I'm going to scroll down here. Okay, this is a Wikipedia article that shows an example of what a JSON is, right? A way of storing data. So this does look kind of large right now, but this is just a data structure. You can think of it as a dictionary that holds key value pairs. Right? So we got first name John, last name Smith, right? And then a bunch of other data down here. These are actually nested dictionaries. So we'll talk about nested dictionaries in just a bit. It basically means we have multiple dimensions, right? Things within things. Okay. So let's kind of build up to that. All right, I'm going to jump back to the lesson now. All right, this is just a sneak peek notebook. So I'm going to go back to lesson 7. Okay, lesson 7. There we go, dictionaries. Here's a little visual on what it can look like. In particular, this notebook is going to use a scenario where we're translating animal names to their scientific name. For example, a lion, the scientific name is Panthera leo, and then so on right here. Okay, as we saw earlier, the notation for creating dictionary is with curly braces. You can do it in one line, like this right here. Right, like you can copy this into one line. It's arguably hard to read. So if you want to make things more readable, we can just add some new lines here. So I'm just going to add a couple of new lines. And there we go. This is a lot easier to read. Okay, I'm going to run this cell. And once again, there are 3 key value pairs in here. Right, the length of this is 3. Right, length is a good function to tell us how big a data set is. All right, once again, I do want to mention that this notebook, we're dealing with hard-coded values. Hard-coded values mean we have data that's dumped into the source code. Typically, the data comes from elsewhere, and in a future assignment, we'll download data from the internet, and it's going to store it in a dictionary. But I hope that kind of makes sense what it means to hard code. Right? It just means we have data inside of source code. Okay, yeah, we can have an empty dictionary. The minimal syntax is a curly brace. Right? We saw that earlier. And we can just verify that animals is a dictionary. Right? It is a dictionary. So I'm going to go ahead and print this. Print fast dictionary. Okay, cool. Let's go ahead and start populating this dictionary. There's only 3 items in here, right? 3 key value pairs. We can populate it with by first accessing it. So you know what? Here, I'm going to make another cell just to help us visualize what the dictionary looks like. So I just made another cell. Okay, animals currently has 3 elements. Right? If we were to access something that doesn't exist, like, oh, I'll do that later. I'll do that later. But we can access things that do exist, like lion. At this, the corresponding value is here. We can go. Let me print it. We can access things like the other one, tiger. Okay, let me print that. Okay, and then bear. Print. Okay, and then bear. Cool. Yeah, we saw this earlier. This is accessing values by their key. All right. What if we were to access something that doesn't exist? Like So once again, I'm adding another cell, just so I don't have to scroll up and down a bunch. I'm adding another cell so I can just visualize what animals look like. What if we were to access something that doesn't exist, like a cat? Right? Cat is not a key inside of this dictionary. So this is going to evaluate to something called a key error, meaning it doesn't exist. But we can make it exist with something called the assignment operator, a fancy word for equal sign. So I can say, hey, this is now equal to Felis Sylvestris, and then yeah, I'll just leave it as this right here. Yeah, this is assigning a new key value pair. So I can go ahead and press enter. Control enter, which is going to play the cell. There's no output, which makes sense because this is just assigning something. But if you did want to look at the resulting dictionary, you can just type in animals at the bottom of the cell. And we see that there is a brand new key value pair. Okay, any questions about this so far? Okay, so yeah, this is just an example of adding something. Once we can do the opposite of that with the delete keyword. It's just like lists. You might remember from a couple days ago, we can access an element and then delete it. Right? It's the same with dictionaries. So if we were to, let me make another cell and delete an item. Like let's say I were to delete, or here, let me do this in a different order. So I'm going to access animals at tiger. Right? This is going to evaluate to this over here. We can go ahead and delete it. All right, so I'll go ahead and delete it. And there you go, it deleted it. We don't see it, but I can go ahead and add another cell and just kind of visualize it. Right, add another cell, animals. And yeah, we see that tiger got deleted. So we're now down to 3 things in here. Okay. Be careful about notebooks because it's possible to run the same cell over again, which can possibly mess up the dictionary. For example, if I were to run this cell again, it's going to give an error, right? Key error tiger. That's because we already deleted it, so this no longer exists. So yeah, if you get this, it's possibly because you ran it twice. And if you want, you can start over, right? You can just go to the top and reinitialize it, or you can just reset the kernel and run everything again. Okay, hope that makes sense. Okay. Let me go ahead and reinitialize this animals back to its original 3 elements. So I'm just going to copy this over here. There it is. Reinitialize. I'll make this easier to read. Okay. There we go. Okay, once again, the length of this is 3. So let me just verify it. We're reinitializing this dictionary. Okay, cool. 3. Okay. Let's see. Yes.
Exactly. Is it proper that you put your last curly bracket not indented? If you were to leave that curly bracket at the end of the error line, it would work properly.
Oh, good question. Why did I put this curly brace here? It actually doesn't matter. If you put it here, it's actually still going to be the same.
Still going to be still recognized. It doesn't have to be not indented.
Exactly. Yeah, the spacing here doesn't matter too much. You could put a space here, put a space here. It could be here as well. I think this is just a small thing. I'm actually abiding to something called the Google Style Guide. You don't have to know this unless you're joining the next Python class, but the Google Style Guide is a guide that a lot of Silicon Valley companies use. It defines how things should look like before submitting it. So Google, oh, this is the C++ one. Let me see if they have a Python one. Let's see, this is C++. Google Style Guide, Python. Okay, let's see. It is a little dense to read, but somewhere down there, it's gonna formalize why I put the curly brace there. Okay, let's see. Okay, let's do a couple more, which will give us enough to get the lab done. Okay, this next part of the lab is showing us Boolean operations that we can perform. Sometimes it's necessary to search data. For example, maybe we want to see if something exists. Like let me reinitialize animals again, just so I don't have to scroll up and down a bunch. So I'll reinitialize animals. Sometimes it's necessary to search data before we do things to it. You might have seen in the last lecture, we would use this in keyword, which will verify if something is in it before we access it. So this is a Boolean expression that evaluates the true or false. Right, so lion in animals. Right, this is going to evaluate to true. It is case sensitive, so if I did an undercase lion, right, this is false. Okay, so yeah, keep in mind for that. Once again, this is useful because you might want to search data before performing something on its value. So I would refer to the last lecture where we did stuff with that on lists. Okay. We saw a key error earlier. When we attempt to access something that doesn't exist, like here, if I access animals, sloth, but this doesn't exist in the dictionary, so it's going to give us a key error. One way we could avoid this is by checking if it exists in it first. Right? Or you can actually just use a dictionary function. The creators of the dictionary provided us with a function called get. Right? This is a class function, meaning it's going to use these parentheses instead. So animals.get sloth. Right? This is not going to give us an error. Right? Basically this function has some protection inside of it. It's basically returning nothing if it doesn't exist. So just to prove that, right? If I print this, it's going to print a none. Right? That's because this function deep inside, it has something like this right here. Right? If it's checking to see if it exists, and if it doesn't exist, it's just going to return none. Okay, we'll talk about functions in a couple of weeks, by the way. So I hope functions will make sense later. All right. Any questions about this so far? Okay. All right. We're like halfway done with the lesson. This is actually enough to get the lab done. So let's attempt to get the lab done. And after that, we'll talk about data structures, which is a way of combining things. In particular, we're going to do dictionaries within dictionaries. And then later on, we'll do lists within dictionaries. Okay, so let's get used to single dimensions first before we add more. So let's go ahead and load up the lab on dictionaries. Lab number 7. Here we go. And yeah, make sure you run the first cell. This way we can check for feedback. All right, I'm going to start a 15-minute timer for folks to try this out. We should have enough to get all of this done. Yeah, we have enough to get part 1 done, but not part 2 yet. Part 2 is on data structures, but we'll do this at the later end of class. But yeah, let's get part 1 done. Put a little timer here. And then folks on the Zoom, feel free to let me know if you're stuck on anything, and in person. If you're on the recording, please try it out yourself once again before we go over it. Okay. I'm going to pause the recording here. Okay, everyone, we are back from intermission. Hopefully folks gave that a shot. Let's go through this together, and then we'll spend the remaining time finishing up the lesson and then talking about data structures. Okay. this first part is asking us to create a dictionary with 4 key value pairs. So I'm going to go ahead and create it here called courses, and I'll set it equal to an empty dictionary for now. Let me go ahead and populate it. Okay. I'll just prepare the skeleton first. So I'll go key value pair here, another one here, another one here, and one more. Okay, cool. So we got CIS-15, which is our class, programming with Python. Another CIS class, a introduction to networking. This one's a fun class, by the way. I took this with Rick Graziani. Hopefully folks have had the pleasure to take it with him. CIS-90. This is also a great class too. Introduction to Unix. Okay. CIS-75. Computer Security Fundamentals. Okay. And you don't have to do this, but I'm going to take advantage of Jupyter Notebook showing the last run value, which is courses. So I'll press play here. Okay, I'll press play again, which is going to run this bottom cell. Play. There we go. All tests passed. So we successfully created a dictionary. Okay, the next questions or the pieces of the lab are going to ask us to kind of access things and modify things. So this second part asks us to access the value associated with the key CIS-15. Now, once again, with dictionaries, we're accessing with keys. In this case, it's CIS-15. CIS-15 will return us this value here, programming with Python. Okay, and you press play, play, and then play. There we go. Oh, attention needed. Didn't call the print function. Yeah, I forgot to print it. So let me go ahead and print this value. Okay, there we go. All tests passed. Okay, now we want to update the dictionary to change CIS-15 to just some string called my course. Right, so we do have to access the dictionary, the element first. Right, so we're accessing the CIS-15 element, and then we can go ahead and reassign it. Right, so I'm reassign it my course. Okay, let me press play. There we go. All tests passed. Okay, a couple more. Now we want to add a key value pair. In particular, this one doesn't exist. Right, just to prove it, I'm going to make another cell so I don't have to scroll up and down. Right, so this cell, right, this is what our dictionary looks like. It doesn't have CIS-54. Right, so I'm going to go ahead and add it. Right, so courses, CIS-54. Now, once again, this doesn't exist because there's a key error. So I'm going to assign it a new value. I'm going to say set it equal to introduction to relational databases. Okay, and you know, I'm going to put courses at the bottom so we can see it. Okay, so let's press play, and there we go, right? A brand new key value pair. Okay, and all tests pass. There we go. Okay, one more, or a couple more. Let's go ahead and remove CIS-81. Right, we want to remove this key value pair. Right, so let's access it first and then delete it. So to access it, courses CIS-81, right? This is accessing that pair, so we can go ahead and delete it. So delete it, and let me once again look at it. Right, look at it right here, and then there we go. Right, CIS-81 got deleted. Okay, and then you can't run it twice because it's already deleted, right? So if we attempt to delete it again, it says, oh, it doesn't exist. So be careful about running the cells twice. Okay. Finally, we want to write a Boolean expression that searches to see if it exists. Okay. We saw in the lesson that we can use the in keyword. We could test if CIS-81 is in courses. Okay, so the expression is this string in courses? Right? It should return false because we deleted it up here. So let's see. It evaluates to false. Perfect. And all tests pass. Okay, cool. Any questions about this so far? On Zoom. Okay. All right. Let's go back to the lesson, finish the stuff on data structures. And then we might have enough time to end off with a real life scenario. Earlier in the beginning of class, I introduced a JSON file, right? Object notation, which is a way of storing data. Likely, if you download data from the internet, like let's say you have access to a Twitter API, and you did a statement that downloads someone data. Right? It's likely that the data will be formatted in a JSON or a fancy formatting for dictionary. So that's kind of a real life scenario. We might have time for this. Okay, let's jump back to the lesson on data structures. So lesson number 7 here, we ended off here on data structures. It's going to look a little confusing because we're going to add another dimension. Right, we're going to have things inside of things. But let's start off with dictionaries within dictionaries. Okay, uh, so here's a new dictionary. It's called organism. Now, what is the length of organism? Right? How many elements are in the outer dimension? There are actually 2 of them. Right? There's this key value pair and another key value pair here. So hopefully people know what I mean by outer dimension. Right? So there's a key plant and a key animal. That's all there is in this dictionary. And just to prove that, right, you can go ahead and go length organism. Right, the length is 2. Okay, it might look like more, but you have to dive into the other dimensions to kind of count them up. All right. So yeah, dictionaries within dictionaries. So let's go ahead and visualize the value in animals. Right, so we're going to access this value. Right, this is actually a dictionary. So here's what organism looks like. Right, this is the whole dictionary itself. A Jupyter Notebook kind of renders it, and it's arguably hard to read. But as long as people kind of keep track of the curly braces, you might be able to read it. So we got plant that's associated with a single dictionary here. And we have animal that's associated with this other dictionary here. And so, yeah, just kind of try to keep track with the curly braces. But let's go ahead and visualize animal. Okay, once again, this is going to return us the value associated, right? This highlighted part. So I'll go ahead and press play. And you see what it returned? Right? It's a whole dictionary, the inner dictionary. So let's go ahead and access things inside of it. Right? This is the part where we will dive into it. So organism, animal, right? We can add in another set of brackets. The reason why is because this evaluates the dictionary, right? So we can access inside of that dictionary with another set of brackets. I'll go bear, and that should access this piece right here, Ursus arctos. Right? People cool with this so far? Okay. And yeah, we can go into another dictionary, right? Once again, organism does have the plant one, right? So we can access this other one with plant. Okay, so plant here, then I'll press enter, control enter. There we go, right? There's another dictionary. And we can go inside of it, right? Dive into it and access redwood, the key, which will give us this right here. Okay, so let's go ahead and access redwood. Okay, we're cool with this so far. All right, cool. Okay, let's go ahead and study some lengths. So this is what the dictionary looks like so far, right? We haven't changed it. Let's see what the length of the plant dictionary is. Right, so the plant dictionary here, just see if we can predict it first. Right, it's pretty much saying, what is the size of this dictionary here? It's not 4, it's 2. Right? There's 2 key value pairs. There's a single comma in here. So if we take the length of it, we should see 2. Okay. We can populate inner dictionaries similarly. Right? We just have to dive into it. So let me try to access something that doesn't exist first. Right? So here's what our dictionary looks like. Right, let me access something that doesn't exist. Like, okay, this dictionary does exist, plant. But inside of it, is there a key named buttercup? Right, there is no key named buttercup inside of here. So this is going to give us a key error. Right? It says, oh, no buttercup. We could go ahead and make it exist with the assignment operator. We're assigning a new value. Nucleus. Okay, and let me go ahead and visualize it. Organism. Press play. And yeah, there we go. Right, we have a brand new inner value. Okay, hopefully people are cool with this so far. Okay, and similar to adding, we can delete. All right, if we want to delete the inner element, then you have to dive in again. Right, so if we wanted to delete this key value pair here, right, you have to dive into animals and then dive into bear. So we can do that. So yeah, go ahead and try this out. I'll just do it here in a separate cell. So I'll access organism, animal. I need to start staying consistent with my quotes. So it actually doesn't matter if you're using double quotes here or single quotes. But I'm going to use single quotes to be consistent. Okay, so this is accessing the inner element here, right? This key value pair. So we can go ahead and delete that. So I'll go ahead and use the delete keyword. This is just one way. There's so many ways on deleting things. And take a look at organism, and we should see it gone. Right, there we go, right? Animal now only has these 2 elements. Okay. Let's do one more thing. Let's say we were to add something to the outer dimension. Right, so here is our dictionary again, our organism. Right, there are only 2 key value pairs in the outer dimension. Right, we got plant and animal. Let's add something to the outer dimension. So I'm going to attempt to add something called fungus. Now, one way we can do that, right, is just access fungus here. Right, this is the outer dimension. It doesn't exist yet. There's a key error, but we can once again make it exist by setting it equal to something. Right? In this case, it's probably appropriate to set it equal to an empty dictionary because we're going to plan on populating it with things. So here's organism fungus, and let me go ahead and visualize it. Okay, so there we go, and we see a brand new key value pair. The length of the dictionary is now 3, by the way. Right? Plant, animal, and fungus. The fungus does have an empty value, so let's go ahead and fill it up. Right, let's fill it up with a shiitake mushroom. So we can go ahead and go like this, organism, and then go into fungus. Right, but then access the inner one. So I put another set of square brackets. Access shiitake. Right, this, once again, doesn't exist. Right, it's empty, it doesn't exist. It'll give us a key error, so I'm going to assign it something. Okay, I'll assign it lentinula edodes. Okay, there we go. Fungus, which now has a dictionary that contains only 1 key value pair. Okay. Okay, any questions about this so far? Dictionaries within dictionaries? Okay, this is just an intro, by the way. Towards the later end of the semester, right, we're going to do more complex data structures. So this is just an intro. It's going to be pretty cool, actually. towards the, yeah, on the 15th week, we're going to do data science. And that's going to be using large data. Right? Large data meaning possibly millions of elements. And those millions of elements needs to be organized somehow. Okay, but right now we're dealing with hard-coded data. Hope that kind of makes sense. All right. So let's see. I'm probably going to let folks. I'm going to help folks out with this part 2 on data structures. If you want, you can try it out yourself. Go ahead and pause the recording and try it. But yeah, this part 2 in the lab is practicing data structures. But it's not going to be a dictionary within dictionaries. It's actually going to be lists within dictionaries. And so you see how there's square brackets here? This square brackets, if you remember from Tuesday, these represent lists. Okay, so it's slightly different. Okay, so let's go ahead and do this together. If you're on the recording, yeah, I do recommend doing it yourself. Okay, I'm going to load this data structure in. And let's study it real quick before we kind of analyze things. All right, what is the length of this dictionary here? All right, well, let's see. And hopefully you guessed 3, right, because there are 3 key value pairs. Okay, what about this? What's the length of to-dos at work? All right, that's saying grab this value. Right, what is the length of this? Okay, hopefully you guessed 2. Okay, yeah, just studying this a bit. All right. Okay, let's go to the first question. It says print the grocery list in to-dos. So it's only asking us to access this element here, right? This list. So we can go ahead and access it by its key, groceries. So print, actually I'll access it first. So to-dos, and then we do access it by its length. I mean, its key. I see this, oops, misspelled groceries. Right? See how it's returning a list? Right, this is not a dictionary, by the way. The lesson had dictionaries within dictionaries. This is lists within dictionaries. Okay. Cool, cool. So there we go. We accessed it, and let me go ahead and print it. Okay, there we go. Let's go ahead and dive into the list. Okay. I'm going to go ahead and do another cell, just so I don't have to scroll up and down a bunch. This cell is going to let us visualize what to-dos look like. Okay, that's what to-dos look like. It says use the print function to print the first item in personal list. Okay, this is asking us to access the value at personal and print the first element. Okay, so let's go ahead and access that list first. So to-dos, personal. Okay, personal, there we go. All right, we accessed the value here. This is going to be a little different though. Right, this is a list. You could look at the type. Right, list, as you might remember from Tuesday, we can access individual elements with the index. Right? Index is the position. So if we wanted to access the first item in this list, right, we do have to use a number. Right? It would be number 0. Right? People kind of see that. Hope that doesn't look too confusing with all these square brackets. But this highlighted part is a list. So we're saying grab the 0th element at that list. Okay, and evaluate to, yeah, get exercise. So let me go ahead and print that. Okay, there we go, get exercise. And yeah, all tests pass. Cool. Let's go ahead and change some items. So add another cell so we could visualize what's going on. To-dos. Okay, this third one is asking us change this milk element to oat milk. Okay, we do need to access this list first. So this list is accessed within groceries, to-dos, then groceries. Okay, so there we go. We access the list. Now we need to dive into it. We got to dive into the first element, right? Milk. This is the first element, so we're using number 0. Right, there we go. We accessed it, and now we just have to change it. Uh, so I'm going to set it equal to, right, I'm going to reassign it a new value. In this case, it's asking us to set it to oat milk. Okay, and let me go ahead and visualize it here. To-dos, press play, and there we go, right? That element got changed. Earlier it was milk. Yes, Jim.
Is there an easy way to look at the groceries and find the index of milk?
Oh, good question. Is there a way to look into this list and search for milk? Yeah, there is. That's a search function. So if you wanted to search for something in the list, one way you can do it is by using the in operator. Like we could say, is milk in into dues, and then groceries. In this case, it's false, but I think you might be building up to, can you find the position, right?
Yeah, is there a simple, easy way to do that without going on?
Yeah. Uh, there is a way to find, I think it's actually a function called find. So let me look at the list Python functions. I think there is something for that that will return the index of where it found it. So let me look at lists. Okay, is there a search function here? Yeah. Bro, let me just control F this. I'm just going to search this whole web page. There's search. Yeah, there is. So this function is called .index. And
So if you were to go square brackets groceries, um, dot index
Mhm.
milk.
I believe so. Here, let me test that. Let's see. Let me test that real quick. So let's go to-do list groceries, and then I'll do a .index. I'm gonna do something that does exist actually, like a cereal,
Yeah.
and then it gives us 1.
Oh, there you go.
Yeah, that's a good question. So yeah, for folks on the recording, someone was asking, can we search and find the position of something? Yeah, you can. One way is with the index. Another way you can do is with a loop. We won't cover loops until after the midterm, actually. But yeah, pretty much I looked at the primary documentation. I did a control F. Control F means find, and I just looked up search, and it showed up here. There's probably other functions that will let you search it, but this was the first one. Yeah, that was a good question, Jim. Question. Okay. If you want to dive into a rabbit hole, this is probably a linear search. It's a linear search, meaning the algorithm, the index function is a loop. It's a loop that checks each element and stops when it finally finds it. Okay, cool. All right. Okay, all tests pass. Sweet. Okay, let's go ahead and delete an item. So let me go ahead and visualize it again. To-dos. Okay, remove check email. So it wants us to remove the second element inside of an inner list. All right, so let's go ahead and access that list first. To-dos. Right, and access the one at work. And then go ahead and access check email. Oh no, so this one is a list actually. My bad. So we're going to use an index. Right, this is the index right here, and then we can go ahead and delete it. Right, that says delete this one here. Okay, so let's do that. And to-dos. Okay, there we go. Yeah, we deleted it. And then, oops, I ran it twice. Yeah, careful on running it twice because I deleted it already, and now it says it doesn't exist, which makes sense because um, it's out of bounds, right? The to-dos only has the index 0, right? So 1 is out of range, right? It's past here. Okay.
So, you know what I did was, rather than use delete, I just reassigned that to an empty string.
Mhm.
And it did pass, but I see that there's still work, still the two long, two in
Mhm.
lambda two.
Oh, yeah.
So I did, it passed the test,
Mhm.
but it wasn't exactly what.
Oh, okay, I see. Yeah, yeah. So someone in class, instead of deleting it, they just replaced this with an empty string. Yeah, that's technically not deleting it. It's kind of just making it empty. The list will still be 1. I mean 2. The feedback thing isn't exactly robust, so it's possible to fake your way through the feedback thing. Yeah. Okay. There's so many ways on removing, by the way. I do want to go through a bunch of ways, but this is the simplest way to remove for now. I guess I could go over one way. Earlier, Jim was asking me how do I search and return a position. Yeah, let's do one more way, just so people are cool. I do have to reset this list though because I deleted it. So you don't have to do this. But I'm gonna go ahead and reset my list. Let's see, by rerunning this cell. So I'm just gonna rerun all of these. All right. Okay, we're back down to delete an item. Okay, so let me just do a cooler way. Let's do a cooler way on deleting. In particular, a more general way that might be useful. So remove check email. Right, earlier, we kind of just hard coded the position. You might remember here we hard coded 1 here because we can see where it is. But in the application, real life application, it's likely that you won't know where it is. So a more general way on representing this solution is by kind of searching it, right? Like this 1 is technically hard coded. So we can replace that 1 with a function that returns the position of where it found it. Right? So if you rewind like 5 minutes, you'll remember that I did something like find the index, right? Like I'll name something called position, right? This is going to store where it found it. And in particular, we're searching for work, but the function index, right? Because index returns where it found check email. So just to kind of decrypt this a bit, this is a list function. Right? We're asking this list, hey, find the index of check email. So it's going to return a 1. Right? Position becomes 1, and we can just put it here. Right, so let's go ahead and look at that. And there we go, right? It's just another, in my opinion, more general way. Okay. Cool, cool.
Of course, you could put that all into one line.
Oh yeah, yeah, you can totally put all this in one line. It will be a little less readable. Uh, so if you're working with coworkers, they might spend some time reading it. So you could put into one line like this. I've actually worked on some projects that had really long one-liners. Really long. Uh, and you know what? People will see these one-liners towards the data science part, the lab 18, like week 14. We'll see some long one-liners. Okay. One more, and then we're pretty much done. Okay, add a new category to to-dos. Okay, this one is asking us to create a new outer dimension. Right, so here's what our to-dos looks like so far. All right, it only has 3 items in the outer dimension. This one's asking us to add something called packing with the following items. All right, so this is like the lesson. I'm gonna go back to the lesson. So towards the bottom of the lesson 7, you might remember this over here, right? This organism. We're saying, hey, access the outer dimension and start with something empty. Right? We could do it this way. Right, so yeah, let's do that. There's so many ways, but we could say, hey, to dos. We could say, hey, make a new key value pair called packing, but we could set it to an empty list. Right, so this is. Let me go ahead and visualize this to dos. Right, there we go. Right, we have packing with an empty list, and we can go ahead and populate it. Right, you can populate this 1 at a time, or you can populate it 3 at a time. I'm going to do it 1 at a time. Right, so access the elements inside of packing. Right, and you might remember in the list, there is a function called append. Right, so we can append, meaning add an element to the end. In this case, I'm going to add clothes. Right, and there we go. We see clothes, and we can just rinse and repeat. So let me repeat with shoes, and then wallet, and there we go. Right, there's 3 items in here. Okay. All tests pass. All right. Hopefully that kind of makes sense on data structures. Right, you can think of them as things within things. Okay, so we're actually done with this lab. This lab isn't due until next week, so yeah, keep in mind for that. Okay, we're probably going to end early actually. So here, let me use the remaining time to go over a possible real-life scenario. Okay, you can kind of imagine a scenario where you have access to an API. Right? An API is short for Application Programmable Interface, which is kind of like access to tools. You can imagine maybe you're data mining, right? Like maybe you want to use a company's API to download someone's data. You can actually do this, by the way. Right? For example, Twitter. Right? Twitter has an API that provides people with the ability to download other people's data. So imagine that you had abilities to do this. It's likely that when you access data, it's probably going to be formatted in a dictionary style. Right? And for here, this is a JSON file. Right? It's just a fancy dictionary. So let's say we downloaded someone's data. Right? So here, I'm going to pull up an empty notebook. Pretend this is an empty notebook. Right? And you can kind of imagine we're using company tools. Right? Imagine we had a Twitter variable. And imagine you said like Twitter dot download data, and maybe we're downloading data from some person named John Smith, and then store this in something called data, right? So we're just imagining. It's likely that this API, right, this tool, will be returning a dictionary. Right? For now, I'm going to hard code a dictionary because I actually don't have access to this API. I actually used to have access to it, and then they started charging a lot of money for it, so I don't have access anymore. But I'm going to hard code it. So hard code means to dump data into source code, which is not as general. Let me go ahead and copy and paste this. So copy, and then let me go ahead and paste it into here. Right, there we go. I just pasted a whole nested dictionary of lists and other things. I do have to change a couple of things though. Python literals, this should be capital true, because Python uses capital for its booleans. And then right here, null. Right, Python represents null as none, as a literal. So let me go ahead and load this in, press play. Right, now we have a whole dictionary called data. So check this out, right? Data, type of data is a dictionary. So once again, we're imagining, right? This is hard coded, but just imagine we downloaded it using that imaginary function I had earlier. We can access things inside of it, right? So let me look at the data, right? There are a lot of things. I'm going to introduce a few functions that aren't mentioned in the notebook. Dictionaries have a function called keys, which will tell us what keys are available. Right? See, they have this many keys. First name, last name is alive. Right? So I can access data at first name. This is going to return a single string. John. Let's access the last name. Smith is alive. Right? True. This is a Boolean, by the way. Okay, it's not a string. Okay, and then age, address. Okay, it looks like address returned another dictionary. So just to scroll up a bit, right? See how the key address, its associated value is another dictionary. So we could dive into it if you want. Right? We could dive into the, maybe street address. So street address, and it gives us, yeah, this one right here. And yeah, we can access pretty much everything in here. Okay, let's access another one, children. So let's access children right here, and we see that it returns a list. Just to prove it, the type is a list, right? And yeah, we can go ahead and access things inside of it. Like lists are indexed by their position, so we can go 0, 1, and 2. Right, and then yeah, that's a 0, 1, and 2. 3 would be out of bounds. Okay, hopefully people kind of see a real life scenario on this. All right. We're gonna end like half an hour early. So let's do some concluding thoughts. We are done with dictionaries. On next week, week 3, we'll give a sneak peek into this new programming project called Weather. This one is going to apply what we just learned. In particular, it's actually going to download data from a website. There's a website, it's called Open Weather, I forget what it's called, Open Weather. But yeah, I'll talk about this next week. It's pretty much going to use an API to download weather data. That weather data is going to be stored in a dictionary. And the whole point of this project is to access things inside of that dictionary and print it. Okay, we'll talk about that next week. But yeah, let's have a great weekend, everyone. Thank you for attending, and thank you for watching.